Welcome everyone once again to the agroecology webinar series. My name is Evelyn Zuniga and I am one of the communications officers for the Agroecology Partnership Project. If you haven't been here before, I want to tell you that the Agroecology Partnership officially started in January 2024 and is funded under the Horizon Europe program. It currently unites the European Commission and 72 partners across 26 member states, associated countries, and third countries. The partnership seeks to support the agriculture sector to meet the targets and challenges from climate change, biodiversity loss, food security and sovereignty, and the environment. This partnership combines the resources of the European Commission and participating countries to fund advanced research that generates essential knowledge and innovative technologies closely aligned with its primary goals. This is the fourth webinar in the series Agroecology Crops. And throughout this series, we have been exploring key practices, challenges, and innovations that contribute to maintaining healthy and productive crops for resilient ecosystems. Just a housekeeping announcement, please feel free to put your question in the Q&A and the chat section that I have enabled for everyone. I'm going to do my best to address as many questions as possible with the time that we have, which is around 40 to 45 minutes. Today, we are very fortunate to have Dr. Akanshka Singh and Dr. Naimides Narriaga from FIBL. So just let me share my screen 1 second. There you go. This one. I think it's coming up in a second. Perfect. Dr. Singh is a researcher at the Research Institute of Organic Agriculture, FIBL, and the Department of International Cooperation in Frick, Switzerland. Her research spans diverse cropping systems, biological control, and multiple interaction, investigating how plants, pests, beneficial insects, and soil organisms interact, especially under organic or agroecological farming regimes. Her contributions beyond research include the co-authoring of fact sheets for organizations like FAO on ecological pest and disease management in the tropics, helping translate research into farmer-friendly tools. She also takes part in international dialogues and collaborations on agroecological transformation, resilience, seed systems, and policy, linking science with institutions and practitioners. Dr. Esnarriaga is a researcher in intercropping and sustainable cropping systems, she's based in Basel, Switzerland. Her research focuses on sustainable agriculture and agroecology with a special interest in innovative approaches such as syntropic agriculture. She explored how these systems can enhance biodiversity, improve soil health, and strengthen farmer livelihoods. She has co-authored international studies on plant interactions and sustainable farming, contributing to the link between science, practice, and policy. And as part of a multi-institutional team, including ETH, Zurich, and FIBL, she helped to review 67 cases of syntropic systems worldwide, assessing their impacts on productivity, ecosystem services, nutritional diversity, and restoration potential. Dr. Singh and Dr. Esnarriaga, thank you very much for joining us today. I'm sorry, I forgot to say that the title of their talk today is Farming Systems Comparison in the Tropics, which is part of the SysCom Project. Dr. Singh and Dr. Esnarriaga, thank you very much for joining me today. And I'm just going to stop sharing my screen and you will be able to share your screen. Thank you so much.
Should I share my screen? Okay.
Yes, you can start sharing. It's perfect.
Okay. Yes, thanks a lot for the introduction, Evelyn, and we are happy to share some of the results of our study and some of the insights that we have. Yeah, thank you again for the introduction. So today, Naimeen and I will talk about some of the insights of our work on the SysCom project, which is Farming System Comparison Trial in the Tropics. And I will first give a little bit of results on the long-term trials that we have established since 2007. And then Naimeen will give a specific example of one of our farmer survey studies that we did. Okay, so let's go right in. So why at all focus on the tropics? So if you look at this image here, even until a decade ago, most of the evidence that was coming on the performance of organic systems in comparison to conventional systems for multiple parameters like biodiversity or carbon was really focused in the temperate region. So we can see here a lot of work coming from the USA and from Europe. And there was very little evidence coming from the tropics. And tropics are, of course, quite different from the temperate systems, not only biophysically, so climatic differences, we have these soil quality differences, but we also have very different farming systems. So this graph here shows the density of smallholder farmers in the globe. And smallholder farmers here is defined as farmers who have less than 2 hectares of land. And what is very clearly visible is that specifically looking at Africa and Asia, that there is a high density of smallholder farmers in these regions. So this means that their practices are different and their path to adoption of solutions would also potentially be different. So with that in mind, in 2007, the SysCom program was established by the Research Institute of Organic Agriculture. It was established in 3 countries, in Bolivia, in Latin America, Kenya in Africa, and in India. And in each of the country, the crops that are the focus crops are chosen based on relevance to that specific region of the country. So, for example, in Bolivia, we are looking into cocoa production systems. In Kenya, we are looking into maize-based crop rotation systems. And in India, we are looking into cotton. In each of the countries, we then have different local collaborators and our partners who are implementing and are collaborating with us in the project. And also in each of the countries, the systems are slightly different. So, for example, in Bolivia, you have not only organic and conventional, but we also have agroforestry and monoculture. So these are the different layers. So the trials are really adapted to the local conditions. So let's go more into cotton, which is the focus of today. So if you think about why was it even needed to look into these organic cotton systems? So over 2 decades ago, the GMO cotton was introduced in India, and it completely changed the landscape of cotton in the country. It was subsidized, widely promoted by the government, and it was introduced specifically to control a lepidopteran pest. It's called a bollworm, different species of bollworms. But what it led to was that because this was also high yielding variety, these GMO cottons, it has really led to large losses of local varieties. And until today, 95% or over 95% of cotton seeds in the country are still GMO cotton seeds. It's quite difficult to get indigenous varieties or organic varieties. And what this also led to is a complete change in dynamic of pests in the country. So the graph here on the right is from a study from 2020, which looked into the impacts of BT cotton in India. And this graph is looking into what are the expenditures on insecticides. And here you can see that when BT was introduced to control for lepidopteran pest, over the years, the amount of pesticides or cost bought for this has reduced, but the other kind of pests, which are the sucking pests like aphids, whiteflies, chassis, these are sucking pests. Spraying for these has significantly increased. And these varieties also have a very high fertilizer requirement. So not only can farmers not store these seeds and reproduce them because they don't have the rights, they always have to buy. In addition, there is high cost of pesticides, there's high cost of fertilizers. And until today, cotton really remains one of the dirtiest crops in the world. So that is a crop which requires one of the most highest used of pesticides. So with that in mind, so organic cotton production or sustainable cotton production is critical. And Now I will just briefly explain our trial. So this is our trial site here where SysCom India was established. So this is based in central India. This is the cotton belt of the country. This is what the trials look like. And we are working closely with Biore Association. These are our partners. And this is a local farmer organization. They work with farmers on not only agriculture aspects, but also on health and education. And the soils in the region are vertisols, so very heavy clay soils. And the farming systems that we are comparing since 2007 are you have the GMO cotton grown conventionally, then we have non-GMO cotton grown conventionally, then we have organic systems, and then we also have biodynamic systems. And we have biodynamic because farmers in the region are already practicing some of these biodynamic methods. So this was a system that we adopted in India. And cotton here is grown in a 2-year crop rotation. So it's not grown every year. And this is also the practice of many farmers in the region. So for example, if in 1 year you're growing cotton, then the next year in the same field, you would grow soybean. And in the middle, you would grow wheat and chickpeas. And chickpeas has only been introduced in the last 4 years. So yes, these are 4 systems, and these are the crops that are grown. And we have been taking data on many parameters since 2007. So for example, labor cost, input cost, soil health, soil fertility, soil nitrogen, phosphorus, potassium, plant NPK, soil pH. So data has been taken on many of these parameters. And I will just show some of these results. First on productivity and profitability. Okay. So let's look at the productivity of cotton. So this graph here is showing you the yield trends in cotton over the years. Here we have on the x-axis year and yields on the y, and the red and the orange are the yields of organic systems, and green and blue are BT conventional. So what is clear here is that, yes, we have very yearly fluctuations. But until about 2019-20, the yield of conventional systems was significantly, specifically GMO cotton was high. Over 25 to 30% yield gap existed. But what is changing since 21 is that yield gap is reducing. And in many years, you even see since 21 organic systems to have similar yields. And one enabling factor that has helped in this is that there are high-yielding organic varieties. So in the beginning, I had mentioned that organic varieties was a challenge. So when the program was set up in 2007, a few years after, there was a spin-off on developing organic cotton seeds. And this was started about 10 years ago with Feeble and also Biore. And of course, breeding good varieties is a long-term process, and it took a while to develop varieties that are bred under organic conditions and are high yielding. And we hypothesize this is one reason that we have these good yielding varieties, that we have managed to reduce this yield gap. And the second reason is we again hypothesize good fertility management, which we will also see a result later, that as soil fertility has increased over time, it has had a positive impact on the yields. So although the initial challenges of fertility and yields varieties are reducing, we are seeing new challenges, not just for cotton in our side, but for farmers worldwide, which are these climatic challenges. And specifically in our area, it is erratic rainfall. So cotton is a crop that when it is matured, in the last stages specifically, it needs no rain. It needs a dry season so that the bolls that you see here are mature They're open and they can be dry enough to be picked. What is happening in the past 4 or 5 years is that we have rainfall that is coming at this time when the bolls are matured. And this is having negative impacts on cotton yields. So earlier it was coming mainly when the cotton was growing in the reproductive stages. So it's from so this also has a strong impact. So we see over the years that how these challenges change and how you need to adapt now to different challenges. And now in our work, since 2 years, we are looking more into how we can develop these more systems adapted to these changing climates. And the second crop, which is crucial for farmers in the system, is soybean. So this is also becoming increasingly a very relevant cash crop in the region. And it is part of this 2-year crop rotation of cotton. And what we see very clearly here is that the yield of soybean is not really affected by management. It is a legume. It can fix its own nitrogen and is not affected by input amounts, at least in from our data. And similar results for legumes have also been observed in other long-term trials. So People has another trial called a DOK, which is based in Switzerland, which is running since 40 years, and similar results we see also from there. But again, for soybean, we see over the years, yield reducing in all systems. And again, we are assuming to test this, that this is potentially again due to rainfall, because this is a crop that is grown during the rainy season. And if you have dry spells between two rains, it can have impacts on the yield. So again, we start to see this rainfall being a big challenge in the production systems in our region. So this was a little insight into the productivity, but of course, for a farmer, what is crucial is what are the profits that they are getting out of this. So we also this year published on the profits, the growth yields of these systems. So here on the right, you can see production cost on the y-axis for the different crops: cotton, soybean, and wheat. And the greens here are the organic systems, biodynamic and organic, and the reds are the conventional and conventional with PT. So what is very clear is that, yes, the total production cost is highest for cotton. It is also has the longest lifespan, so it takes over 5 to 6 months to grow. And specifically, if we look overall across all the years, yes, corn BT systems have a higher input cost, mainly because of fertilizer and yields. But what is changed in the last years is that organic systems start to have higher cost in the last 4 cycles. And this is mainly due to high labor cost in cotton specifically. So in general, the cost of labor has increased, or how much they are paid per day, that has increased. But what is also increased is that if the cotton yield in organic has also increased. And one of the significant cost factors in cotton is picking of the cotton balls. It is done by hand. And specifically in organic, these balls tend to be more sticky and more difficult to pick. And this also leads to higher costs over the past few years. And we do not see that for soybean again. So in soybean, the labor costs remain low in organic systems, and also the input costs remain low. And how then, if you combine now this profitability, the production cost, and the yields, then we get a clear picture of what the gross margins are. And here again, we have at the bottom, the cycle. So here it is a cycle because it's like a 2-year rotation cycle. So we combine these rotation here, and we have the gross margin for the different crops. So what was clear was that most of the variation in the gross margin, at least until 1920, until 4 years ago, was driven by cotton. So cotton plays a very strong role. And one thing to highlight here is that cotton is the only crop that gets a premium price because it is exported. The other crops have to be grown organically, but they do not get any premium price. So they are sold at the local market price. So until 20, we had this really mainly driven by cotton. And as yields of cotton were higher in conventional systems, this was higher in gross margins were also higher in these systems. But what changed specifically in the past 4 years was that chickpea was introduced in the rotation. And this was done because chickpea has a very high market price, specifically the specific varieties of chickpeas, and farmers in the region were also adopting this practice. And this really led to significant increase in this introduction of this profitable crop for the local market, plus higher yields of cotton, really led to high gross margins in organic systems in the past 4 years. So diverse crop rotation is specific, quite important for be thinking of these sustainable production systems. So here were some results from our long-term trial. We also wanted to look at what is happening at farmer fields, and in 2020, in just 1 year, we did a survey in farmer fields, and each of these points that you see here are farmer yields. And on the right, we have organic, on the left, we have conventional. So what we found interesting was that if you look within a system, the yield difference between the farmers, organic or conventional, is quite high, over 300%, and between systems is only 10%. So what we assume from this is that these are the farmers with high yields who are doing effective management practices, probably have more resources. So often this good management can have more impact on yields than just organic or conventional farming. So extension services and trainings are quite crucial in these systems. So if we summarize some of this work on productivity and profitability, so we would like to highlight that organic systems can positively affect yields and profitability, but it is important, effective management is important, and systemic approaches are important. So looking at the whole rotational system and not just a single crop. And often the yield gaps that are reported for smallholders can be overestimated and can vary for species like legumes. And so it's quite important that we are diversifying the systems with crops targeted at the local market and not just focusing on the cash crop. The system-based approach is quite critical. Okay, then I will briefly just share just a little bit on two results on soil and beneficial species. So looking at the ecosystem services, again, most results coming from the long-term trials. So soil carbon is a crucial parameter for healthy soils. And in a recent work, we looked at the soil carbon over all the years. And here we have the years in soil carbon and the different systems. And what we find is that the soil organic carbon, specifically in organic systems, the variation is only starting to be observed after 8 to 10 years, with slight increase in organic systems and slight decrease in conventional. So in the initial years, the systems were similar, but if we look until 2025, there is a slight increase in organic and slight decrease in conventional. And what is quite interesting is that when we looked at the yields and correlated the yields with soil organic carbon, we found that in organic systems, there was a strong correlation between the yields and the organic carbon, which was not observed in the conventional systems. Of course, because conventional systems also get many other inputs that react quickly in the soil and can be taken up. So there's a stronger relationship in organic systems. And then also for microbial community, we have some one-year data set that has shown that obviously the organic and conventional systems have very distinct microbial communities. For example, in the organic system, you would have taxa, which is linked with phosphorus mobilization or organic matter breakdown, whereas in conventional system, it would be taxa, which is linked with nitrifiers. So, yes, and also pathogens. And finally, we also find higher abundance of beneficial species or beneficial fungi like trichoderma species in organic systems. And also, for example, biocontrol insects. These are again 1 or 2 year data from the long-term trial site. So if you look on the graph on the left, these trichoderma species are almost absent from conventional systems. And if you look at the graph on the right, you do have beneficial species in these PT conventional, but there's just higher abundance in organic systems. So just summarizing this quickly, so we find that we have higher soil carbon, but it's a long-term process. Organic systems can increase diversity of beneficial microorganisms and insects, which in turn leads to reduction in need for pesticides. But the key message here is also that sustainable farming systems do take long-term to show the benefits, and that's why it is critical to support smallholders in the initial transition phase in the years. Okay. So with that, I would hand over to Naimid. So I told you in the beginning, we have also this participatory on-farm research platform where we work closely with farmers. And as part of that, we did this survey in farmer fields. And Naimid, you can please take over.
Thank you, Akansha. So now I'm going to talk about the socioeconomic factors and agroecological practices effects on soil fertility in these systems. Here we have another approach. This the participatory on-farm research is basically a collaborative approach where farmers and researchers work together to design and also conduct experiments on the farm fields. And the objective here is to address the real problems of the farmers and try to find a solution. With these experiments, here we can collect qualitative and quantitative data. The next thing I will show part of our result. First, I want to give some insights of the context, why we wanted to link the socioeconomic factors, agroecological practices, and effects on soil fertility. Because the organic cotton farming, and actually all the organic farming, requires agroecological practices to enhance and sustain soil health. They cannot rely on chemical fertilizers. And also there is a lot of studies addressing that the farmers' socioeconomic factors influence the use of these practices, which indirectly are going to impact on the soil fertility. In this, the aims of our study was to assess the effect of those agroecological practices. We detected 9 practices on soil fertility. And also we wanted to understand the relationship between this use of agroecological practices and the socioeconomic aspects on soil fertility. So for that, we integrated 2 interviews per farmer regarding the use of those practices and the socioeconomic aspect of them, like age, level of education, if they belong or not to a tribal community, the experience they have in organic farming. And also we collected 2 soil samples to detect also the soil biophysical characteristics. And this was done before harvesting and during the cropping system. For the agroecological practices, we adapted an agroecological complexity index that is the sum of 9 practices. We have on-farm biodiversity that contains the border crops, trap crops, or intercropping, crop rotation, if they incorporate cotton residues or not, if they use compost or not. Then we have compost effective management. When the farmers that they use compost, they also cover and turn the compost. And the farmyard manure management that also includes the practices of composting, covering, and turning. Then we have if they have or not livestock, and if they train in soil fertility. And the last one is if they have legumes, if they incorporate legumes in the field. So the first results regarding this is a big panorama of the use of these agroecological practices for the farms. So we can see here that more than 90% of the farmers, they have livestock, and they also access to training in soil fertility. And we have also that more than 50% of the farmers, they use legumes. They also incorporate crop residues, and also have a good farm manure management. And the rest of the practices are less used, like compost application, crop rotation, and the compost effective management. So this is the use of those practices for the farms. So now we are going to see if there is some insights of socio-economic aspects that can affect the use of those practices. How is the next piece. So we have the education level. We have 3 levels of education. The lowest is in yellow and the highest is in violet. And we can see clearly here that the one in the middle and the highest education level, they cover more agroecological practices than the lowest group. So I can go later, in details, but you can see clearly which are the practices, like for example, the incorporation of crop residues, composting, and farm general management are more used by those farmers than the one with the highest education level. Also, we have the years of experience in organic farmer. We have 3 groups of farmers from 1 to 10 years of experience, 11 and 20, 21 and 30 years of experience. And here we can see also that the most experienced farmers, the one that are with purple, violet, they use more, for example, composting, and they also have a better composting effective management than other farmers, and also rotation. So there is some differences between the group of farmers regarding socioeconomic aspect and the use of practices. And also something that for me was very interesting, because we have the next, please. We have the hypothesis that usually tribal communities of Aboriginal communities, they use more, or they are more familiar with agroecological practices. But in our study, we actually found it the opposite. But maybe it's because the sample was very small, were less than 10 farmers that actually belongs to a tribal community, or also could be the effect of that for a long time there were some extensionism programs with somehow a colonization maybe of the agronomical knowledge of the farmers. So now we can really don't measure that maybe is we are not really accurate in this kind of result to see if real tribal communities, they use more or not agroecological practices. Then we also wanted to know how the soil Yeah, the next, please. How the soil fertility parameters are influenced by some of these agroecological practices. And among all these practices, the one that has more influence is the percentage of legumes. We can see that the percentage of legume increased the soil pH, the soil microbial biological community, carbon, sorry, organic percentage of organic carbon, and the quantity of phosphorus in the soil. And regarding organic matter, we can see that the incorporation of cotton residues also slightly increased the percentage of organic carbon, and also the rate of organic manure increased the organic carbon percentage. So we, of course, I cannot not show all the results. We really don't have enough time, but we have the conclusion that the interplay between socioeconomic factors and agroecological practices strongly shapes soil fertility in organic cotton systems in the Nimar Valley. And the big message is that boosting agroecology requires both research and policy support that integrates both practical and socioeconomic dimensions to improve farmers' understanding and decision making regarding soil fertility. Thank you very much.
Okay, that's excellent. Thank you very much, both of you, for this presentation. It was really amazing to see. Like at least for me, it's very important to see that you need a really long-term experiment to start seeing changes, like at least in carbon content. It is just mind-blowing that it really needs to be a long-term experiment. So just to tell people, please, you can put your questions in the Q&A section, the chat section. Like in the meantime, I just have like you kept answering the questions that I have, but I have some here. Akanshka, you mentioned that uh, one of the things that are driving prices up is the cost of labor for farmers. So I was just wondering, are there any automation schemes for farmers in India to reduce the time or kind of the effort that they need to put into kind of collecting the cotton, preparation of the rock phosphate, manure application, or everything has to be kind of done by hand, or is there anything that, I don't know, the government could be helping them with?
Yes, thank you for your question. Yes, so labor is indeed a big challenge. And there are schemes coming out for that. For example, if you think of cotton, what they are trying to do is, it would probably take a long time, is that they're trying to even develop varieties that can be picked by machines.
Okay.
And so
Okay.
these kind of elements, but it is also, I think, more than of course, technical solutions are critical for this and should be done. But we also have to think then what happens to the labor class that is doing this, because often for them it's the only source of livelihood. So, for example, in one study, we were looking at labor dynamics in organic conventional systems, and almost, I think, 80 to 90% of labor work in cotton is done by women.
Okay.
And many tribal women, many low-class women. And for them, it's a very important source of livelihood and food security even. They use most of the income for food, for example. And what they mentioned was that organic farming, which is bad for the farmers, so it's like a trade-off, gives them higher bargaining power. So cotton is sold by kilo, and cotton for picking, labor's demand by kilo. And as often organic has lower yields, they demand higher price, and it also takes longer to pick. So they actually can bargain more for organic than conventional. So yes, there are there are schemes to reduce labor, and there should be a focus, but then it should also be a focus to think that, okay, what will we do with the labor class? Like, should they be given some stable money every month or not? Because one complaint we also hear is that yes, this scheme is coming, but this will make the people not wanting to work. So it's, I think, quite critical that what works for the farmers and laborers together. It's a complicated solution
Yeah, it is. It
problem.
is. It is complicated to, yeah, marry those things. I have a question for Namit. So, uh, from the farmer's point of view, what are the biggest challenges when they switch? Like, if you kind of maybe saw that when they switch from conventional to organic way of growing the cotton.
Um, I mean, in all these farmers, the service was done in organic, already converted.
Oh,
They
very
are
cool.
certified organic. Yeah.
Okay.
But usually, in my experience, it takes a lot of time to really do the transition, to start the transition, even
Mhm.
not to really, because of course it's going to depend a lot of the programs that are supporting those farmers during the transition, most economically and with addressing real practices. You cannot incorporate all the agricultural practices at once. So it's a really a very slow process usually.
All right. Okay. We have a question from the audience. It says, in India, GMO cotton had been cultivated for many years. When conventional methods were used, was the same land used for cultivation? And then the next question is, did the properties of the soil change after the cultivation of BT cotton GMO?
Mhm. Yes, thank you for this question. So the field where we have our trials, so there was no cotton was not grown there. So we grew wheat there to standardize the soil. And so we don't have a clear indication if it is really the effect of because we have two systems, for example, conventional and GMO. So one has conventional and non-GMO variety, and one has GMO variety and conventional. So there's an indication of a recent study that we published that because is one thing is the variety, but also is the fertilizer requirement of the variety. So the GMO cotton requires very high amount of fertilizer. So you give a lot of nitrogen. And what this nitrogen can lead to is that it can lead to large losses of carbon as well. So we don't have a clear answer yet, but in this study, we find that the carbon stocks are the least in the GMO conventional system. But we don't know why it is. Is it because of the variety? Is it because of the high amount of inputs that are given to this? So this still needs to be looked into. But for sure, when you give high amount of fertilizers, it does have impacts on soil carbon because it leads to higher nitrogen priming by the bacterial community.
Mhm. Okay, I have, it's 9:46. Just one last question. I don't see anything in the audience at the moment. So, the final question could be, do you think the lessons from this project in India can be scaled up to other regions where cotton is grown around the world?
Mhm. Yes, I would say, for example, maybe similar soils. So vertisols, there are many regions in the world with vertisols, so we could assume that similar patterns might be seen there, especially when it comes to soil, because soils, how they change it's very strongly affected by the inherent property. So potentially could be, but aspects on productivity and profitability potentially could be scaled. Because yes, if there's an improved organic variety that in other regions is developed for that specific context would also benefit there. Or good management is crucial for farmers, or good extension training services would work anywhere. Yeah. So in some aspects, yes, some aspects not.
All right. Naomi, do you want to add anything?
No,
You okay?
yeah.
Okay, so yeah, I think I need to leave it like now because it's 2 minutes past, 3 minutes past. So thank you very much, Akanshka and Naimit, for joining us today. Oh, we have one question. Is it soybean for livestock feed or human consumption?
This soybean, the one they grow, it's not BT soybean, so
It's not
there's no
between. Okay.
GMO. There's not GMO soybean,
Mm-hmm.
no. Some farmers also consume it, but many also it's also for livestock.
For
Yeah,
livestock. Okay.
yeah. There's
Okay.
a very big push by the government right now to grow soybean.
Oh,
Okay.
really?
Yes, this is growing really vastly spending,
Okay.
but it's still
Okay.
at a small scale level.
Uh-huh.
Mm.
Okay, I see. Okay, so I just have to kind of thank you so much for joining us today. It was a really insightful presentation about cotton and how it's grown and these long-term experiments. Very important to see how the changes can be manifested over the long years. And thank you everyone for joining the webinar today. And thank you to my panelists, Akanshka and Naimit. Thanks so much. So I'll see you around and have a great day today.
Thank you very much.
Thank
Okay,
you. Thanks a
goodbye.
lot.
Bye.
Goodbye.
Bye.